This week we are going to learn about C# properties, and then we'll discuss how they relate to encapsulation. And basically, C# property is a private field that you will be binding to a set and a get method. So what we've been doing up until this point is we've been creating our private fields within a class, and then we have been creating our own set method and our own get method. And what C# properties do is they kind of automate that whole process and make it a little quicker and easier to code. There are two different ways that you can create properties. The first technique is called a regular property syntax, and you'll see that we've got a private field, and then we create a public field with the same exact name. And then within the public field, we have a get and a set method that are returning the value of the private field and setting the value of the private field. And you'll notice in the set, we have a variable called value that is built in. So when you create the regular property syntax, you do not need to include parameters with the set. Okay? The value that you're going to use is automatically included. Okay, so that value is assumed and it has the name value, and you set that to the private field. So it helps to see a C# example. So here I have an example with first name, and you can see here it is the private field. And then I create a field with the exact same name that is public. And then I've got the get and the set. And so now you can kind of see how that value works. Okay, and you might be thinking, well, this is not any different than what I've really been doing. Okay? In fact, it might be more typing because now I've got to do public. So this type of syntax is typically used if there is some kind of a condition that you need to check. And you're going to do a little bit more than just returning or setting a value. Okay? If all you're going to do is return a value and set a value, then you typically use the auto-implemented syntax, which is super quick to code. With this syntax, you are giving it your access method. You're giving it a data type. You're giving it the field name. And then you just simply code get and set, and that's it. So here's an example, public string first name. Same example we've been looking at, get and set. Everything else is generated behind the scene. So the private variable is generated. The get and set accessor methods are generated. Okay, and this auto-implemented syntax you will use when you don't have to check for anything special. So there's no if statements that you need to include in the get or the set. Okay, so this is super fast and super easy. So this statement is basically equivalent to what we've been doing here with declaring the private field and doing our get and our set. Okay, one little statement does all of that. Okay, and so how exactly does that work? Well, this is all built into C#. So when the compiler sees this statement, okay, public string first name get set, it actually generates all of this. So it knows that, okay, we've got a private field called first name, and then we've got our get and our set methods that we're going to create. Okay, so it knows that this single line of code actually is equivalent to all of this, and it generates that for us. So by default, the get and the set methods are public. Okay, and so if for some reason you did not want them both to be public, do you have to then code? Do you have to use the second technique, the regular syntax? No, you don't. All you have to do is put private in front of the one that you don't want public. So if it's the set that you want hidden, then you put private in front of set. You probably would never do that in front of the get because then they would not be able to retrieve the value. And so, but if you want to control uh, actually setting the value, then you could put private in front of set. And what that would do is that anything outside of the class would not be able to set the value. It would have to be done inside the class. So how does this support encapsulation? This C# properties basically hides the private field. Okay, so the person that is using them, you're not even aware that the private field exists because you don't have direct access to it. You're using either the get accessor method or the set accessor method. Okay, and those two methods are the ones that have access to that private field. Okay, so that is how it supports encapsulation. Now, I mentioned that you can do some customizing in the get and the set accessors. And so if you do need to do any kind of checks, then you need to use the regular syntax. And this is an example of the regular syntax where we've got a private field, okay, and the field is called name. And then we create the public field with the get and set accessors. And so you can see in the get, I'm not just returning name, I'm actually converting it to uppercase. Okay, so that is something that is a little extra, and that is why I can't use the auto-implemented version. And in the set, you can see that I've got an if statement, and I am checking to make sure that the value is not null and that it's not equal to blank. And if it is, if it's not null and it's not blank, then I put the value into name. Otherwise, I set name to an empty string. Okay, and so because I'm doing these checks and it's not a straight assignment statement, okay, that is why I have to use the regular syntax. The most common use of C# properties is to include both a setter and a getter. Okay, but do you have to include both? No, you do not. If you wanted to only include set, you can omit get and code it like this. Likewise, if you only wanted to use a get method, you could. Is that the way these are normally coded? No, but there is the flexibility to code it that way if you want to, if there's a need for you to code it that way. So far, we have been doing kind of normal fields that have not been properties. So how would you go about converting a normal field into a property? So here I've got a program, and this is how we have been doing it. We've had our private fields in a class, and then we've got a constructor We got a constructor that receives the past data. And then we've got our get methods and we've got our set methods. Okay, this is how we have been doing it. And then you'll notice down here, when we are in our main method, we create an object, and then we use that object to invoke or call the get method. And down here, we're using the object to invoke or call the set method. Okay, and so that's pretty much what we've been doing up until this point. Now, if we're going to convert this to C# properties, because if you look at our get and our set methods, we are not doing anything special in those, right? There is no special code other than the assignment statement and the return statement. That means we can use the auto implemented syntax. Okay, and so this is going to make the program a lot shorter. Okay, because now instead of having the private variables and all of those get and set methods, we just create a public field or variable here, and we use the get and the set. And behind the scenes, what it's doing is it is generating the private field, and it's generating the get and the set method for us. Okay, so we don't have to code all of that. We just code it this way. Now we still have to do the constructor. And if we want to have a constructor that accepts parameters, we still have to code that. Okay, but with the auto implemented version, we do not have to code the private fields, and we do not have to code the get and the set methods. So that saves us quite a bit of time in coding up the class itself. Then in the main program, how we access the fields is a little different. We still have to create an object. Okay, so we create the object just like we did before. But now, instead of using the get method to retrieve the value, we use our object dot and then the property. Now, what's going on behind the scenes is it is actually, because we have get and set here, it has generated the private field and it's generated the get and the set. So behind the scenes, it is using that auto-generated get to retrieve the ID. And the ID is stored in the private field that was generated. Okay, but as far as how we code this in our main method, it is just the object dot property. Okay, and for the name, it's the same thing. The object dot, and the property is first name. And then object dot last name. How do we set values? It's kind of the same way. We create an object. Okay, and you can see that this one is using the default constructor, the one that is setting it to zeros and blanks, okay, because I'm not passing it any data. So then I am using the object dot property, and I'm setting that equal to 20. So what it's doing is it is now using that generated set method. Okay, that entire method is generated behind the scenes. It is using that to access the private ID that is generated behind the scenes and assign 20 to it. So you can see how this supports encapsulation because the private field and the entire method is hidden. I can't see them in this program, but they do exist. They were generated. Okay, and so member.firstName works the same way. So we've got first name here. The set method was generated. So it's going to use the set method to access the private first name field and assign Wilma to it. And it does something similar for last name. Okay? And then if I'm going to write the data, I need to retrieve it. So all I have to code is the object, which is member, dot, and the property. Okay? And then it goes behind the scenes, accesses the get method, which then accesses the private field ID and retrieves it. Okay, same process goes on for first name and last name. So you can see how slick this is, how quick it is to code, and how powerful it is because it's generating so much code in the background. So that was the auto-implemented version. Now, what if we have a program like this? And you can see this is the old way that we were coding it before. We've got all of our private fields. Okay, and then we've got our constructor that is assigning default values. And then we've got our get methods. Okay, and we've got a set method here as well. And you can see that for our set price, it is actually doing more than one thing. And we have an if statement. Okay, and we've got the same thing for quantity. Okay, so in this case, I cannot use auto implemented for these fields. Okay, so what I have to do for at least for quantity and for price is I have to use the regular property syntax, okay, because I need to include those ifs. Within main, because this is our old way of doing things, we've got our object, and then you can see we're using the object to call the set method here. And we're using the object to call the set method here. Okay. And then we're calling a print function, and down in the print function, that is where we are calling the get methods. Okay, so this is the old way of doing it. And this is how we would convert it into the new way. So our new way of doing this, we still are going to have our variables here declared. You can see that we are using auto implemented here for already assigned and reorder. And I'm assigning them default values of false. So with auto implemented, can you assign default values? Yes, you can do it exactly how I've done it here. Then for price and quantity, we are using regular property syntax. And that is more because of what we have to do in our sets. So for the get, this is pretty straightforward. We're just returning that private field. Okay, we're doing that in price. We're doing that down here in quantity. For the set, that's where we have the if statement. And so this looks very similar to what we had before. Okay, so we're basically seeing that if it's not already assigned, then we assign the price and we change already assigned to true. And for quantity, we're checking to see if it's greater than or equal to 0. And if it is, we assign the value to quantity. Okay, and then if for some reason the value is less than 10, then we do need to reorder. So we just turn reorder on and set it to true. Okay, you can see we do have a constructor down here as well. And that's another thing I wanted to point out. The constructor does not have to be the first method. Okay, you can see that we've got these properties defined first, and then we've got the constructor. Then within our main program. So now that we're using properties instead of our set and get methods, this does change how we are going to access the data. So we still declare our object, but then we use the object dot property, okay, for the value. Before it was product, I think, dot set price, and then in parentheses, we had the read line, and now we have a straight assignment statement. So that is different because now we're using properties. Okay, and so if we take a quick peek, that way you guys can see, this is how we did it before. Set price was a method, so we had to pass it what we read from the console. And now, because it is a property, we can just use an assignment statement. The same goes for quantity. That is an assignment statement. The old version would have had product.setQuantity, and then in parentheses, we would have had our console.readline. The call to our print is the same, but if you look down in the print method itself, instead of p.getPrice, now we are accessing price directly. And instead of p.getQuantity, we are accessing quantity directly. Okay, so that is another difference when you are using C# properties. So in summary, C# properties do make assigning and retrieving values easier because you can use the object dot property, okay, like member dot price, instead of calling a method. So instead of using member dot set price or member dot get price, you can just use member dot price. Okay, and if you were going to use set price and get price, you'd have to have parentheses and you'd have to pass data, and now you don't. Okay, so that makes it easier. And if it helps, what we can do here is a little comparison, right? So if our object is called member, now we would just do member.price, right? Okay, that's how we would access it. And let's say we're going to set the price to 10. Okay, so that is how we do it with C# properties. And how we did it before is we'd have to say member dot set price. And then we would either use, a console.readline, or we could even just pass it the value. And this actually would take the value and pass it on to the set price method. Okay, so this is with C# properties, and this is without. Okay, so just two different ways of doing it. The two ways to code the C# properties are auto implement or regular syntax. You can use auto implement when you don't require any kind of validation or checks in your set and get methods. So I'm giving you another example, and this one, you can see we've got a couple different private integers. We've got ID and department, and for strings, we have name and title. And then if we take a look, we've got ID. So this would be our public properties. We got department. So this is using the property syntax, although it would not have to. Okay, because we're not doing anything special, this would be something that we could do auto implement. Okay, down here in the main program, because we are using C# property syntax here, then we can use the object, which is created right here. We can use the object dot property to assign values, and we can also use the object dot property to retrieve the values. Okay, now remember when I looked through here, I said we could easily do this using auto implement. That to me would be the preferable way of coding this. And so we'll take a look at that. Same exact program using auto implement. So this now is our employee class. So what we have 4 lines versus the regular syntax, which is here. And I haven't even counted the number of lines, but it's a heck of a lot more than 4. Okay, so this is regular syntax versus auto implement. Okay, so auto implement is a lot faster and shorter. Okay, and also Visual Studio, once you are starting to key these in, it will actually fill in the get and set for you. So I don't know if you have noticed that, but let me see if I can show you what I'm talking about. So let me get rid of a couple of these. So if I'm going to do public, okay, so here it's got string name. If I just press tab a couple times, it will write it in for me. I think the other one I had was title, right? Of course, you have to do this without typos. And basically you just keep keying until you start to see that fill in. And this one for some reason didn't. But once you see it fill in, oh, that's because I misspelled public. Let's try that again. Oops, I think I missed it. There it is. So now if I just press tab, I've got it and I don't have to type it. Okay, so for those of you who don't like to do a lot of typing, and I would be in that category, this is pretty awesome. Okay, so that is another reason why using auto implement makes coding faster. So that is kind of the end of our C# property key points. If you do have any questions or if you are confused about anything, please let me know. And I hope you enjoy coding this way because it is fast. And I think eventually you will find it to be quite easy.